This class is for class 9 and we are discussing congruency of triangles. In the previous class we have done questions of exercise 10.1 and we have discussed all the questions. We haven't left any question so that you may understand how to write the proof of any given question. But in this exercise we will be doing questions in the multiples of 2 because I expect by now you would have learnt how to write the proof. In the previous exercise we have discussed questions based on SSS and SAS congruency, that is side and side angle side congruency. Now we will be discussing about ASA or AAS and RHS congruency. So first we start with the question number 2, means we are doing questions in the multiples of 2. So first is question number 2. They say in a triangle ABC and PQR. So we will make two triangles. Let's make two triangles ABC and PQR. Let's say these are two triangles ABC and PQR. Now they say that in this angle A is equal to Q. What is given? First point, angle A is equal to angle Q, and second point, angle B is equal to angle R. You have to find which side of PQR should be equal to BC side of triangle ABC. You have to find which side of ABC triangle, which side of PQR triangle should be equal to the side of BC of triangle ABC. So we know, and they say that these triangles are congruent. So that the two triangles are congruent means it is given that these two triangles are congruent. We know that when two triangles are congruent, then corresponding elements or corresponding angles and sides of one triangle are equal to the corresponding elements of the other triangle. So angle A corresponds to angle Q. You can see in the diagram. Angle B corresponds to angle R. I have made two lines. Now BC. So first angle, second angle and third side. First angle, second angle and then third side. So we can say that PR, BC should be equal to PR such that it follows the rule of AAS. Angle, side, angle, side, and then we can say so triangle ABC will be congruent to triangle PQR because of this rule. So now in the questions you have to use ASA rule or AAS rule or RHS rule. This is the very basic question. Now we move on to question number 4. Now question number 4, it is given that they are referring to the diagram. ABCD is any figure given, and in this it is given that BM and DN are equal. So BM is a perpendicular from B to AC and DN is a perpendicular from D to AC. So BM and DN are equal means this side BM is equal to DN. You have to prove that AC bisects BD. This AC line is bisecting BD. Bisecting BD means E is the midpoint of BD, or you have to prove that E is midpoint of BD. This is what you have to prove. So what we can say, this and this side is equal, that is given. This is 90, so this also will be 90. So 90, 90, and these angles are equal because they are vertically opposite angles. Now when they are vertically opposite angles, you can see angle, side, angle, side. So by AAS these triangles will be congruent. If congruent, then this and this side will be equal by CP. So first of all we are writing proof, and in the proof we write the triangles which we are considering. So in triangle DEN, in triangle DEN and triangle BME, what do we find? First of all, we can say that DN is equal to BM. Why? Because it is given. Second point, we can say that angle DNE is equal to angle BME because both of these angles are 90 degree. This is 90 degree because DN is perpendicular on AC, and this angle M is 90 degree because BM is perpendicular on AC. Now third point, we can say that angle DEN is equal to angle BEN. Why? Because these are vertically opposite angles. You know that when the two lines intersect, these are known as vertically opposite angles. So you can see that these two are vertically opposite angles. So we have proved side angle, or you can say angle side. So we can say that triangle DEN is congruent to triangle BME by angle side rule. When the triangles are congruent, then we can say that all the elements of one triangle will be equal to all the corresponding elements of other triangle. So we can say that DE corresponds to BE, so DE is equal to BC. So we can write DE is equal to BE. Why? By CPCT rule. DE is equal to BE. Why? By CPCT rule, corresponding corresponding parts of congruent triangles. Then if these sides are equal, if D is equal to BC, so we can say that E is the midpoint of DB, and that is what was required to prove. Now next question, that is question number 6. But one more thing I would like to say, in class 9 you cannot leave any question unsolved. All the questions need to be solved, but in the fair notebook you will do the questions that I have told. All the odd numbered questions are supposed to be in your fair notebook, but in your rough notebook or practice notebook you will be doing all the questions, not leaving even the single question. Now we move on to question number 6. Now in question number 6 they say that L and M are two parallel lines intersected by P and Q, another pair of parallel lines. And in this you have to prove that triangle ABC is congruent to triangle ABC. You have to prove that triangle ABC is congruent to triangle CDA or ADC. What is given? L is parallel to M and P is parallel to Q. This is given, and this is you have to prove. Now let's talk about proof. We know that when two parallel lines are intersected by a transversal, alternate interior angles are equal. It means this angle and this angle will be equal. At the same time, this angle, okay, let's talk about this angle. This and this angle will be equal. You can see that this is line L, this is line M, and this angle, and we are talking about these two angles. These are alternate interior angles. So first, which triangles we are considering? Obviously ABC and CDA. So we will write in triangle ABC and triangle CDA. What is there? First we can say in triangle ABC. So in triangle ABC we are getting angle C. So we'll write angle ACB. ACB is equal to CAD, that is in triangle CDA, is equal to angle CAD, and reason is alternate interior angles. Number one. Second point, we can say if these are two lines intersected by a transversal, we can say that this angle and this angle, they also act as alternate interior angles. So they are equal. So we can say that now, second point, we can say this angle and this angle. So we will say BAC, because BAC angle lies in triangle ABC, and we are writing first about triangle ABC. So that will be angle BAC is equal to angle ACD. ACD, and that is also the same thing, alternate interior angles. Third point, what we can say, that this AC is common in first triangle as well as second triangle. So we can say AC is equal to AC since it is common. So we got what? Angle, side, angle. Angle, side, angle in the second triangle. So we can say, therefore, triangle ABC is congruent to triangle CDA, and reason is angle, side, angle. Two angles and a side included between, similarly two angles and a side included between them. So these triangles are congruent, and that was what was required to prove. Now we move on to question number 8. Now question number 8, this is a diagram given ACDB, and they say angle BCD is equal to ADC. So BCD is equal to ADC. Let us say that this angle is X, so this also will be X, since both these angles are equal. That is up to you, whether you write or you don't write, hardly matters. BCA, BCA and ADB, let us take this angle as Y and this angle as Y. If I join both these angles, means angle C can be written as X plus Y, total angle, and same will be angle D also. Angle D, the value of angle D will also be X plus Y, because these these angles are divided into two parts, and one part of both the this angle C and D is X, and the other part, or the remaining part, is Y and Y. So angle C is equal to X plus Y or is equal to D. It means what we can write, how to write it. Now it is easy for you, because we can make out that this angle and this angle is equal and this side is common. So angle, side, angle, triangle will be congruent. I hope you have understood. Now how to write? So we can say angle BCD is equal to angle ADC, and that is given. Let it be equation number 1. Second, we can say angle BCA is equal to angle ADB, and that is also given. Let us say this is equation number 2. When we add 1 and 2, adding equation 1 and 2, when we add them, we can say angle BCD plus angle BCA is equal to angle ADC plus angle ADB. Now BCD, this angle is X, and BCA, this angle is Y, total angle. Either you write X plus Y, or we can simply write angle ACD, BCD plus BCA. BCD, this angle, plus BCA, this angle. Total will be ACD. So I have written ACD is equal to ADC and ADB. ADC, this angle, and ADB, this angle. Total makes BDC. So you can say angle BDC. This is one proof that you have done. Means you have made the angles equal. Then we can say that this is one proof, means one equation that we have done. Now, when we talk about, this comes to this point, when we talk about in, means in triangle ACD, and this would have came before this. Now we are moving on to this in triangle ACD and BDC. So here I have to write. I was supposed to write here, but I wrote it over here. So this step will come before ACD in triangle ACD and BDC. Now when we talk about ACD and BDC, we can say first point that angle ACD is equal to angle BDC. Why? Because it has been proved above. You will write proved above. Means we are talking about this point. ACD is equal to BDC. We have just proved above. Now second point, you can say that angle ADC, only this angle, angle ACD is equal to angle BCD, only this angle, angle BCD, this is given. Third point, we can say that CD is equal to CD, that is common. Now we can make out angle side angle of the first triangle. Similarly, angle side and angle of the second triangle. So we can say that triangle ACD is congruent to triangle BDC. Reason is angle side angle. Angle side angle. In the second triangle or corresponding angle side and the smaller angle. So by ASA the triangles are congruent. Now when the triangles are congruent, the second point is BC should be equal to AD. So when this triangle ACD is congruent to BDC, then whole BC has to be equal to AD. So second point, you can simply write BC is equal to AD, and the reason is CPCT. Third point, they say prove that angle A is equal to angle B. When two triangles are congruent, you know that all the elements of one triangle are equal to the corresponding elements of the other triangle. So angle A for ACD and angle B for BDC are equal. So simply angle A is equal to angle B. Again the same reason CPCT, and that is proved. Now we move on to question number 10. Now question number 10 says ABC is an isosceles triangle in which AB is equal to AC. This is given which sides are equal. So according to that I have made the diagram. This was the statement. With the statement I draw the diagram that ABC is a triangle in which AB is equal to AC, and I mark these two sides equal. Then they say draw AP perpendicular to BC. So according to the question, AP is drawn and perpendicular to BC. So this angle is also 90 and this angle is also 90. We have to prove that angle B is equal to angle C. We have to prove that this angle is equal to this angle. For this we need to prove that this triangle is equal to this triangle, or we can say we have to prove triangle, we have to prove or you can say we have to prove triangle ABP is congruent to triangle ACP. Now which triangles we are considering? In triangle ABP and triangle ACP. What do we have? First thing, it is given AB is equal to AC, so simply given. Second point, you can say that angle APB is equal to angle APC is equal to 90 degree. This is also given. Why? Because they say AP is perpendicular to BC. AP is perpendicular to BC means this angle is also 90 and this angle is also 90. Third point, what we can say, AP is equal to AP since both AP is common to both the triangles. AP is contained in first triangle also, as well as AP is contained in second triangle also. So now what we see, right angle Right angle and right angles are equal. Hypotenuse, side opposite to right angle is hypotenuse. So this and side and opposite to hypotenuse is this. Both these are equal, and one common side. So we can say that these two triangles are equal because of RHS rule, right angle hypotenuse side rule. So we can say triangle ABC is congruent to triangle ACP. Reason is RHS rule. What is RHS? Right angle. So these two right angles are given in both the triangles. Hypotenuse, this AB and AC is the hypotenuse and they are equal, it is also given. And the common side we can take AP, that is also given. So right angle, hypotenuse side. So the triangles are congruent. Now I think I'm stopping this class, and in the next class the rest questions will be discussed. In case you have any doubt in any of the questions that have not been covered, please send me the question or comment, or I'll be telling you, I'll be helping you out. So by the time, stay home, stay blessed. Thank you.